So this is question 23, paper 1, 2012, higher. Find the equation of L1, the perpendicular bisector of the line joining these 2 points. Well, we really need to get a good picture drawn of this situation. So let's draw an X and Y axis. Now, we do have to make sure that the scales are more or less equal on each axis. So I'm going to consider these as 3 units, so that 3, -3, point P will be down there roughly, and the point Q, -1, 9 will be roughly there. So that's Q -1, 9. And I'm putting all the information on this diagram. That's good practice. And therefore the line through these points, let's put it about there, perpendicular bisector, is at right angles perpendicular to this line, and a bisector means it passes through the midpoint of PQ. So this line, let's call this point M, midpoint. It's the bisector of the line PQ. So QM is the same length as MP. And the line is perpendicular, so roughly there, where that's a right angle. So there's the perpendicular bisector of the line joining P to Q. So that's a pretty good diagram to get going with. So let's have a look at what we would do to find the equation of this perpendicular bisector. So find equation of straight lines. Let's just remind ourselves that we need to know 2 things. We need to know a point on the line, let's call it AB, and we need to know the gradient of a line, of the line, let's call it M. And if we know these 2 things, the equation we're after is y minus b, y minus the y coordinate, equals the gradient times x minus the x coordinate a. So that's what we're working on. We know a point and a gradient, we can work out the equation. So let's find the point M. M is the midpoint of the line joining P and Q. So the x coordinate would be the average, the mean of the 2 x coordinates. So we add them up, divide by 2. So a -1 plus a 3 halved. And the y coordinate will be the average, the mean of the 2 y coordinates, 9 and -3. So it'll be 9 plus -3, add them up, divide by 2. Halfway between each of them. So -1 plus 3 is 2. 2 over 2 gives us 1. 9 plus -3 is 6. 6 over 2, that's 3. Let's put that in the diagram. And it makes sense. 1 along, 3 up. That looks pretty good for the coordinates of 1, 3. The gradient of this line can be obtained from the gradient of PQ. We'll see how in a minute. So let's work out first of all the gradient of PQ, and this involves working with the gradient formula. Remember the gradient formula, the gradient of the line joining 2 points, say A and B, with coordinates x1, y1 and x2, y2. The gradient would be the y difference, that's y2 minus y1, over the x difference, x2 minus x1. We could swap the order around, y1 minus y2, but we'd need to watch that the same order is kept, x1 minus x2, that they're both swapped. In other words, you can't just swap one round. But anyway, let's work on that. So gradient of the line joining PQY difference, 9 minus 3, difference of the two y coordinates, divided by the x difference, -1 minus 3. Now 9 minus 3 is 9 plus 3, which is 12. -1 and another -3, if you like, is -4. Positive divided by negative is -4 into 12 is 3. So we've got -3. And certainly that line is a steep downhill line. If we go along 1, we've gone down 3. Along 1, down 3. So it makes sense. The gradient of a line perpendicular to that line, remember we invert and change the sign, so it would be 1 over -3 but made positive 1/3. Reason being that 3 times the -1/3 gives us -1. The product multiplying two perpendicular gradients always gives us -1. Gradient times a perpendicular gradient is always equal to -1. So that's why we invert 1 upon -3 and then change the sign to positive. 1/3. So the equation of the perpendicular bisector is, so we now have a point on the line and we have the gradient of the line. So we can use this. It's y minus the y coordinate of the point that we know is on the line, y minus 3. The gradient, 1/3, x minus the x coordinate of the point on the line. So let's tidy this up. Let's multiply both sides by 3 to get rid of this fraction. So we get 3y minus 9. Both parts get multiplied by 3, the whole of the left-hand side. If we multiply 1/3 by 3, we get 1. So we've got one lot of x minus 1. And probably get these together. 3y minus x, take x from both sides and add 9 to both sides, would get that. So 3y minus x equals 8. So let's wipe out some of the rubbish that we created and move on to part 2. We should preserve this equation as we're going to need it. So there's the equation of the line L1. So there's L1. And let's move on and look at part B. Part B asks us to find the equation of L2, a line which is parallel to PQ and passes through the point 1, -2. Let's find that point 1, -2, very roughly down there. So there's 1, -2. And there's the line L1 that we've found the equation of. So a new line appears, and there it is, passing through R and parallel to the other line. So that's parallel to that. And we've to find the equation of L2. So we need a point on the line and we need the gradient of the line, and we'll use the good old technique of y minus b equals m times x minus a. So point on the line we have, point on line, let's just summarize that, is the point R. So we have the task of finding the gradient of this line, which we know is parallel to the gradient of the line PQ. So the gradient of this line L2 is exactly the same as the gradient of the line PQ, which if you recall, had a gradient of -3, one along 3 down, steep downhill line. So we have the gradient -3 and we have a point on the line. So the equation of the line is y minus the y coordinate -2 equals gradient -3 times x minus the x coordinate 1. Let's simplify this. Taking away -2 is adding 2. Let's multiply out here. -3 times x. -3 times -1 is +3. And let's just tidy this up. Now let's add 3x to both sides and take away 2 from both sides. And we'll end up with y plus 3x is equal to 1. So moving on to part C, let's again preserve the equation that we'll need, and this time it's the equation of L2 that we're preserving up here. And let's wipe everything else away. Keep the diagram, of course. I think I'll move the diagram lower to make room for the rest of the question. So let's look at third part. Find the point of intersection of L1, that's this perpendicular bisector, and L2, that's this point here, which let's call it N. So we'll call the intersection, this is part C, we'll call the intersection N. And to find N, we solve these simultaneously. So 3y minus x equals 8 and y plus 3x equals 1. Several ways of doing this. I'll get the x's the same, so we'd multiply the first equation by 3 and leave the second equation as it is. So everything in this equation, both sides, gets multiplied by 3. So 3 lots of 3y is 9y. 3 lots of this minus x by minus 3x. 3 8's 24. We were leaving the second equation as it was. We now have a 3x and a minus 3x, which if we add, they disappear. Remember, the whole point is to get one of the letters, x or y, to disappear. So let's add these equations. 9y plus y is 10y. 3x plus negative 3x disappears. 24 plus 1 is 25. So divide both sides by 10. Y equals 25 over 10. Divide top and bottom by 5. We'll get 5 over 2. We'll leave it as a fraction. To get x, we could use the first equation. Let's put y equals 5 over 2 in 3y minus x equals 8. So 3 times 5 over 2 minus x will give us 8. Now that's 15 over 2 minus x equals 16 over 2. Let's add x to both sides. That'll disappear and take away 16 over 2 from both sides. So 15 over 2 minus 16 over 2 will be minus 1 over 2. So x equals minus 1 over 2. So the point of intersection N, and we've said what N is minus a half 5 over 2. Now it's important you now look at the diagram to see if this makes sense. So N does look to be just to the left of the y-axis, that's negative a half, and nearly up at 3, 2.5, 5 over 2. So this looks pretty reasonable. So let's put minus a half and 5 over 2 as the coordinates of the point N. So let's just store this last result, and let's move on to the last part of the question. So there is the part D. Hence find the shortest distance between PQ, this line here, and L2. A little talk about two parallel lines. Suppose you're sitting on this line and you want the shortest distance. Suppose the lines are parallel. You want the shortest distance between you and this line. Now, you wouldn't go off at some sort of angle. You would travel off in a perpendicular direction. That would give you the short, not this one, not this one. That would give you the shortest distance between these two parallel lines. So the perpendicular distance, this distance nm, is what's required here. So the shortest distance, required distance, is the perpendicular one between the two parallel lines. The required distance is nm. And we know that n is -1/2, 5/2, and we know that m is the 0.13. So we're going to use the distance formula. Now, the distance formula involves the square root. It involves squaring the x difference and squaring the y difference. The x difference would be 1 minus -1/2, and the y difference would be 3 minus 5/2. So x difference squared plus y difference squared, square root. 1 plus 1/2, 2 halves plus 1/2, 3 halves. 6 halves minus 5 halves is 1/2 squared. Take the square root of that. 3 halves squared. You can square the top, 3 3s are 9, and square the bottom, 2 2s are 4, so 9 quarters. And a half squared, half times a half, half of a half's a quarter, square the top one, square the bottom one. 1 squared's 1, 2 squared's 4. So 9 quarters plus 1 quarter would be 10 quarters. So it's the square root of 10 quarters. So we can square root the top, 10, and square root the 4, 2. So the shortest distance between these two parallel lines is root 10/2, 1/2 of root 10.